Hello, 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 hi. Thank you all for coming at this pretty late session where I think the conference fatigue starts setting in, so it does my ego enormous good to see a pretty decent audience. That is the thing that worries me. So, thank you very much for coming to a complete beginner's guide to Snowpark in DBT. An apology to start with, I'm doing some slightly fancy-dancy stuff with the screens I've never done before, and that I've not practiced with, so disasters may happen. Set your expectations low, and, well, probably meet them. But if I manage to just slightly get through this, you'll all think I'm a genius, so great. So, my name is Christopher Marland. I'm a Snowflake Solutions Architect at Aimpoint Digital. So that means my life is dedicated to Snowflake. My house looks like a shrine. I get so much swag from them. And the big reason is because I am one of their 70 data superheroes. You can see that on my t-shirt there. Basically, Snowflake have this kind of league of community experts, and I'm one of them. So that's my sort of blue tick, I suppose, literally. Cool. So, is this going? Hey, there we go. So, first I want to talk about Snowpark. What is it and how it's defined? Because definitions, I think, are a little bit fluffy. Python models. If we want to use Snowpark, in DBT, we need to use Python models. To understand them, I think it's really key to actually compare them against SQL models. I think they're very nebulous, I think, unless you are doing comparison. And I think that's what really helped me to understand them. So if you don't understand them, I think that'll be a good idea to go through. Go to an example use case. And this is where I'll start doing a bit of the lecturing, I suppose. But a lot of people, in fact, I heard a statistic this morning that was told to me by an insider, and it was that less than 10% of customers have have one or more Python models in their projects. That is very, very low, really, and I think maybe it should be higher. But there's also a point to make that actually I would say only really about 5% of your project should be in Python at the absolute maximum. The reason for that is, well, this is assuming this is only data engineering. If you're introducing some data science, which maybe you should do in another project now, that's a thing, then you'd want to do a lot more of that in Python. But assuming we're just talking data engineering, because I'm a data engineer, most of you will be a data engineer. If you're a data scientist, I'm very sorry. I really respect whatever it is you do. But so perspective of data engineering, we've got a data engineering project. Only about 5% should be in Python, in my opinion. The reason is data engineers are quite expensive, especially when you want them to be Python specialists and SQL specialists. If you're thinking, well, I'm not expensive and I'm a specialist in both, you're being exploited. Leave your company right now. So that's really the deal. But you will need to sometimes do it. Galaxy brain use cases. And so I'm going to go through a galaxy brain use case, and I know it's a galaxy brain use case because it took ChatGPT ages to write the code. Cool, so I'll go into the demo of that, and then we'll do an appendix, and I put that because I have to put 6 points on the agenda. So, Snowpark, what is it? Snowpark is a set of runtimes and libraries that allow people to develop on top of Snowflake in languages other than SQL. So, really simple definition, for now, is that if you are querying data in Snowflake in a language other than SQL, that's Snowpark. They're then introducing Snowpark container services that might complicate that definition, but it's a definition that's nice and simple, and it works for now. It's also an execution framework, because you may get a bit purist, and if someone's doing something slightly funny in it. You may say, oh, it's not real Snowpark. So that's kind of the wrong way to think about it. It's an execution framework. It's not a specific thing. It's not a specific syntax. It's just a way of querying data that's not SQL. Oh, what have I done? Oh, no. Ah, cool. Python models. So what are they? Simple definition. They are models written in Python. There you go. Goodbye. It's nice to see you. Thank you. So they're going to execute Python code in your data platform. And if that data platform happens to be Snowflake, and I think it should, then Snowpark you use the Snowpark execution framework. In the DBT docs, they make a point about the fact that you can't. Oh dear. Basically, data frame operations, that's the important bit. You're using a data frame. A data frame is the object that you're interacting with and what you're applying changes to. So here's some example code. This is what it looks like. And I'll go into a little play around in a bit. But I robbed this from the DBT docs because I don't believe in writing code you don't have to. Neither do DBT, so it's fine. And this is a bigger thing. Some things that are nice and interesting to look at here. So def model, DBT session. I don't know if it absolutely has to be called model, the function, but just call it that. Don't experiment. I don't want to know. You use that DBT you see here. You then use that to do things like get the configs or get a variable here. And look, I can actually store that in a variable and then use that down here. So you're instantly getting a little bit more flexibility here. Also, you can do the if DBT is incremental. This isn't like a Ginger thing. This is actually in an if-else statement. You can elif it and do all sorts of fancy stuff. So that's a bit nebulous. I think when you compare it to SQL, it starts to make sense. So when I say SQL, I actually mean Ginger. Either the same thing. No, they're not. But when it's DBT, I kind of think of them as the same thing. Ref, curly curly, ref is dbt.ref. Curly curly source is dbt.source. Notice a pattern. Curly curly var is dbt.config.get. It's a bit of a wild card. It's not dbt.var. Who saw that coming? Curly curly config, materialized equals materialization name. You can do most materializations just not a view. So don't do your staging models, perhaps. Except our example in a bit is going to be a staging model, but forget that. Curly curly this, dbt.this. If is incremental is, dbt dot is incremental, and that returns a Boolean. Okay, so let's see. So this is where things get dangerous because I'm on 3 screens and I'm going to live code, except I'm not going to live run. Why? Because the internet is terrible and I'm scared of it. So you'll see, oh, how's that showing up? It's because I ran it before. So the code I'm about to write is going to produce this result, and you're going to believe me, okay? Right? I dare you to challenge me. So I'm going to go into settings. Actually, first, why am I doing this in Snowflake, not in DBT? Because when I'm in DBT, I can't press that nice preview button and see that my code is working. If you want that to be introduced as functionality, you just have to cyberbully DBT, and they'll introduce it, I'm sure. So that's what you need to do. So for now, you probably actually are going to have to do a bit of dev in Snowflake and then move it to DBT. It's a bit awkward, I'm sorry. So just to make things conform, I'm going to change this handler to model. Normally expects main, but I'm going to change it to model. So def model. And in Snowflake, I'm going to have to do this here. This is taking too much time. I'm going to copy and paste. Let's not pretend I'm doing this completely from scratch. So this is just some standard Snowpark functionality. And actually, I think in the interest of time, because I'm blabbling, I am going to do a copy and paste here. So this is just what this will look like. And this isn't working because actually I should have done some imports. So let me just do that quickly. This is not a comfortable interface here. Not interface, setup. OK, so just to explain some things that are going on for those who are not familiar with Snowpark for Python syntax. It's total, if PySpark wasn't open source, this would be absolutely outrageous copyright theft. But luckily it is. So basically, they've just taken the PySpark syntax. What I'm doing is, so I'm creating a data frame here. stg shops equals session.table, and then the table name. And then doing some transformations to this data frame. I want it to be overwritten. With column creates a new column, and I want it to be called shop ID. I kind of want to do the same thing as the generate surrogate key is doing. So what I'm doing here, and you can't use macros in Python models, I'm sorry to say. I see heartbreak across the room, but I'm sorry. So I'm calling it shop ID. Then what I'm doing, call just means I'm referring to a column. Star, you know what that does. Array construct, turning all of those columns into an array. Array to string turns that, well, you know what I mean. Lit is how you say, treat this as a literal thing, as an actual bit of text. I'm not referring to anything. It's not a function. It's not anything. It's just treat it as if it was just a bit of text or string. And then MD5, and that's creating my nice little surrogate key thing here. And then what I want to do from there is I want to then move that into dbt, and let's just copy and paste here. Changes will be made. The difference is now I'm doing dbt.config, introducing that. So it's not put up here, it's put down here within the function. I'm saying I want to materialize it as a table because I can't do it as a view, and I would otherwise. dbt.ref is going to actually refer to the model in your project. And then that creates this std shops data frame. I do my transformations. I do this select down here just because I want it to be in a certain order. And then I return the data frame. Now, I'd love to run this, but I didn't, and actually I should have run this before maybe. What would have been interesting to see? In fact, I'm going to be brave. Let's be brave. I'm going to see if this works. Because I actually like what's going on, I'd like to show you what's going on in the back. Oh, it built successfully. Oh, thank you. Whenever I do a demo and I'm like, you know what? I'm going to just build something, and I'm like, oh, it's going to break. Hey! So, looking here, can you see it's actually creating a stored procedure, or a sproc if you're a cool kid. And it's doing all of this. And this is why you can't actually preview it, because launching stored procedures willy-nilly is probably a bad idea. But that's what's going on. And so that's an interesting thing, because that means whenever you run this, it's going to do two things. It's not just going to apply logic to create a table. It's actually going to create a stored procedure, run the stored procedure to create the table. So it's doing something a little bit different. Cool. So moving back into presentation, I think I'm doing this right, and then click. OK. So that was just a quick run through of how to develop what it looks like. I am hoping understanding is moving and you all see where that's going on. Nods, great, thank you. So now an example use case, because actually what I did there, I did do in SQL, I can do in SQL, I should do in SQL. Because, and again, SQL should be the default, always. But when might you not want to do that? So here's an example use case. Problem statement. So in San Diego, we have distribution centers and we have shops. And I have ambition. I am a bold entrepreneur, and I want my shop, my brand to become nationwide, to become worldwide. And so I'm going to need to do this mapping of distribution centers and shops in a way that's dynamic. I can't just have someone manually saying, that's the closest to that, that's the closest to that, because that's not going to be great. What happens when roads close? What happens when new roads are made? What happens when bike lanes come in and such things? The world is in a state of constant chaos and flux, and your data should be designed to deal with that. That was so profound, wasn't it? You are all amazed. Thank you. So I want a solution that is scalable, dynamic, that is going to keep up with the chaos and anarchy of our existence. How do I do that? I use a Python model. That's how I do it, and I do it in Snowpark. So I have got 3 tables to begin with: distribution centers, shops, and the San Diego road system. And ideally, that would be the entire road system of the planet. But I'm not going to do that because that would cost me like $7 billion to store in Snowflake. So I'm just doing that for now. Then I'm staging the distribution centers and shops in SQL. And I start diving into Python here. Why? So I have longitudes and latitudes here. And to put, as you would imagine, the shop is not literally on the road, or there would be total chaos and cars would go smashing into it. So I need to get the closest bit of road to that shop. That's the starting point. And I use the road grid to do that. That's with those little lines there you can't really see very well. And then what I do, that's it here. Once I've got that, I can then traverse the road grid to say, okay, here's point A, here's point B, which one is near? This is geospatial analysis. Try doing that in SQL. Good luck. You're doomed. So you're best off doing it in Python, in Snowpark. So, calling this a demo, but hell no. I'm going to show you the code that's already run, and you're going to believe me that it worked. Because I actually tested it. Well, I showed you some code, and it did work, much to my surprise. So I'm going to have to flick through a lot of things. So this is what the int grid shops bit looks like. Can I zoom out? Maybe. Is that still readable to people? Thumbs up, great feedback, love it. Guys, great audience. So what's going on here is I am doing that bit where I get the longitude and latitude of the shop and which is the closest bit of road, and just assume that is point A, and if it's slightly skewed, who cares? So you can see here I am doing something dbt.config packages, and I'm bringing in some packages. I do the imports here, but I've also got to state them here in my dbt.config. Really important. Then I've got my Snowpark data frames that I'm immediately changing to pandas data frames. And you think, well, Snowpark isn't pandas. It can be. Who's to say it can't? There's also going to be, and I'm not breaking any NDAs here, there is going to be a specific pandas version of Snowpark as well, which is going to blow things up, I think. So yeah, what I do there is then going through here, I'm just basically finding which is the, getting a point, which is the closest bit of road grid to that point. and then mapping that. So just have a little look at what that looks like. So this is what the roads looks like. It's just WKB's well-known binary, which represents a tiny bit of road, and every time it turns, it'll be another tiny bit, another tiny bit, and another tiny bit. So do this worldwide, it will be expensive, so there better be some profit motive. Then my grid shops looks like this. So I've got the shop ID, the original longitude and latitude, and the nearest road geom, which represents a line string again, so just that tiny bit. Back in dbt, I then want to do my closest distribution center mappings. This is creating my mapping table between each shop and the nearest distribution center. I'm using another package here called Network X. I'm not a big geospatial guy, so don't ask me loads of questions on this. This is not a geospatial demo. But yeah, the basic flow of this is it uses the roads, the shops, and the distribution center. It gets those 2 points, A and B, and goes through, links them up. Doesn't do it to everyone. There is like a sort of mile radius. If it's beyond these many miles, don't bother, it's worthless. And then links them together. And it returns the closest one, the smallest one. So then, at the end, when this has run, this is not it. Mappings. This creates the mapping table. Travel time is in this weird format that I could turn to proper format, but I'd then have to create this like weird thing with curves, and it was just computationally expensive. Like the model runs in about 1 minute on a large Snowpark optimized warehouse. When I tried introducing the curve of the world and make it a proper time, it went up to like an hour, 2 hour, so just wasn't worth it. This is a good enough representation. So yeah, this is my mapping table. You can see there's a few. It will give me a few. So I could then choose from this. I could add a bit more. Just return the minimum. And yeah, that there is a very quick run through on a sort of one of those galaxy brain use cases for which you may want to use Python, Snowpark for your data engineering needs. Okay, great. Appendix. So, add me on LinkedIn. I like publishing things. I might be useful. I don't know. Don't bother doing the following thing because I don't like that. It makes me feel awfully pretentious. Being one of those people who doesn't accept people, just you're going to follow me. Don't do that. The presentation will go out, I believe. That will be published somewhere undisclosed. I have no idea, sorry. I'm going to also be publishing a video soon on a sort of more basic how-to with Python models with Snowflake and Snowpark. That'll go on my company's YouTube, Aimpoint Digital, so if you want to follow them, that would be maybe a good idea. So, thank you. Is there another slide for questions? No, there isn't. So, there's now an amnesty. If you need to go somewhere, I won't be offended if you leave right now. If you have questions, musings, ponderings, considerations, vicious personal attacks disguised as questions, hit me. Come on. Thank you. Go on, go on. The amnesty is in place for 1 minute. Those who need to go, go. Those who've got questions, stick around. Don't worry, I'll take them. No need to come up. If you want to ask a question, stay sat down, it's fine. If you want to listen to questions, stay sat down. I said the amnesty is 1 minute, hurry up. Okay, I think we're probably enough people out. Questions, hands up.
Casper, does Snowpark support CTE? Snowflake said no.
Does Snowpark support a common table expression? No. No, I mean, I would say you wouldn't do it like that. So.
Because the Scala version of the Snowpark supports CTE, but the Python version doesn't.
I don't really know Scala, unfortunately, so I can't really do that comparison. What I would say is it's not as if it doesn't do it, it's if there's just an alternative thing for it. So you can have a function that would return a data frame, and then in your main function, your model function, you could then reference that, use that function to return a data frame.
The data out, that's a problem. I want to have a SQL that runs in Snowflake, not pulling out the data out of Snowflake to do the transformation. And then it can get a little bit more complex. That's where the CDEs come into place, like to simplify, to reduce the execution time.
So I'm not sure if it's entirely true because, well, with Snowpark, it's lazy execution, and it doesn't run until you actually say so. If it's df.show, return the df, or df.collect. So it's only at the point of running that the execution would actually happen. It would go through, and that would happen at that moment in time. So I do believe it wouldn't really add significant amount of times to have a function return another data frame and.
I did some testing.
Okay.
And I talked to the reps, Snowflake reps. Like when I write a SQL, pure SQL,
okay.
Comes back. And when I write the same SQL using data frame, a little bit more complex, right? 500 lines or something.
Is that using session.sql or using Python Snowpark syntax? Snowpark syntax, okay. I do think there is slightly more complication when you're doing it in Snowpark because it's doing that conversion, it's running certain things, it's doing a lot in the back end to actually turn that into SQL and then run it, which is another good reason why I would say actually if it can be done in SQL, do it in SQL, do it in a SQL model because of that extra latency that you are right, it is there.
It went from 2 seconds to 20 seconds.
Yeah. Another question?
You mentioned you wanted your demo, your geospatial demo. You mentioned you wanted it to be scalable. And I guess my question concerns your two pandas. Like if I'm writing in SQL, it will transparently do the partition, or in the background it will do whatever partitioning and scaling needs to do. It's like text-based. What happens when your data is too big to fit into a Python section?
So the question, remember I've got to summarize questions to the stream, is when you want to be scalable and you're converting it to pandas, that actually sort of gets rid of the partition benefits and actually makes it very, very compute intensive. And the very sad answer, I'm sorry, is you just kind of have to deal with that as a trade-off. That is really a problem. And so when you're doing this kind of analysis, and again, another reason why it should be the 5% as opposed to the majority is you are doing something that is going to need big warehouses to store that in the memory of the warehouse and to do complicated big stuff on it. And that's going to be horrible. That's going to be expensive. That's going to be rubbish in its own way. And so you're going to need a very good profit motive for doing something that's so huge. You would have to expect it, yeah. And if you can't do that, then you'll have to work out other optimizations that you can do. But yeah, a very, very sad answer is you have to just accept that as a trade-off. Yeah.
Why would you suggest using Snowpark over like a Python UDF or a vectorized UDF?
So that's a good question. When would I expect to use a Snowpark over a Python UDF or Python vectorized UDF? I can't think of a specific answer right at the top of my head. I mean, I would actually say if you can do it in SQL but using a Python UDF, do that. That's how much of a edge, it's almost an edge case when you wouldn't. That's almost, if you can do it in pure SQL, native UDF, native functions, or maybe SQL UDFs, do it, that's the default. If that fails, Python UDFs, but still in SQL, then in Snowpark, absolutely you cannot do it with the other two. That's kind of like the flow chart, I would say, is the case. Some exact conditions I struggle to think off the top of my head. I'm jet lagged, sorry. But I'd say just as a rule, that's what I would apply as my thinking.
Thank you.
You're welcome. Hello.
Can you give us some more examples of that scenario where you might want to do it? I got Profit running just to see how it would work, to get some operation projections. And I just can't really know what other use cases you've come across.
So one of the use case I've applied is when you need to do really, really dynamic stuff. So one thing I've got in production is I have a schema where, for various reasons I won't get into, expands and declines and expands and declines, and there's an incredible amount of overlap in the tables. And I need to have a sort of running bit of knowledge of how many overlaps there are, but I cannot predict how many tables there'll be, what their names are going to be, etc. So I use Snowpark to basically query the information schema, what's in there, and then dynamically create join conditions on a set of columns that could be primary keys and foreign keys, and I can't even predict that. So when the fundamentals are unpredictable, I think that, and that kind of maybe answers your question as well, perhaps. When the fundamentals are really unpredictable, that's a good time to be moving it into Python, I would say. Any other, I'm over time. Am I allowed to answer another question? Sure. Go on, thank you.
Just, so if you've created how does it behave when you query it? I think that's my question. Is it, because I saw you materialize it as a table.
Yeah.
So is that data set in stone?
Yes.
Or when you query it, does the Python actually have to keep right in and almost behave like a view?
No, it doesn't. Once you query that, you would query that just in SQL, and you can it'll be treated as normal. It will be materialized, it'll be created, and it'll be a table that you just ping. It doesn't act like a view or anything like that. So you don't have to worry about any computation other than just loading from memory.
How do I think of the difference between a Python UDF and a Snowpark model? Is it because it's still holding the data in SQL and applying it to an UDF?
Yeah, so just a general UDF would be row by row, normally maybe just by one column, but you can specify how many columns in a parameter. It's like a Python UDF. An example of when I've used that is when I have HTML tags in data that's come through, and I just want to quickly get rid of that, and there's the Python library that does that. And so it's really honed in, specific, and just going row by row with one or multiple columns is really what I need. And then in Snowpark, you're trying to return a data frame. You're trying to create an entire table. So that's the basic of it. Anyone else? Are we all satisfied? Good? Oh, sorry. You're hiding from me.
I know. Are there any mechanisms for kind of developing a shared library to share between models, like a lambda layer?
Yes. So what you can do is you zip it up, put it into an internal stage, and then you can reference that in the session object. You can tell the session to go into that internal stage and import that as a custom library, essentially. That's the way you do that. Also, if you have libraries that are not supported, if you Google Snowflake Snowpark Anaconda channel, it'll give you a humongous list, but not everything's in there. And so if you wanted to bring something someone else has developed, you would also do it like that, package it in that way.
Support for that in DBT, or does that have to be orchestrated outside of DBT?
I believe so. No, actually, no. I think not, because within stored procedures, I don't think Snowflake allows that. So it'd have to be run as something else. I think. No, I'm going to scrap that and say, actually, I don't know. I'm going to be humble. Is anyone from you work at DBT? No. Okay, great. That was concise, wasn't it? I did the ramble and the open thinking. That was, yeah, great. Any other questions? Anyone hide? Oh, again. Go on.
I've used Snowpark outside of DBT before, which was a mistake. But,
You?
the query plan that gets generated by Snowpark when you're just using Python Snowpark or Python Snowpark collaboration in your Python project is not a stored procedure. Am I incorrect, or if I missed something?
Are you asking if in DBT Snowpark operates in a...
Something different about DBT Snowpark versus just Snowpark outside.
All right, is there a difference between Snowpark in DBT and Snowpark running wherever else you want it? Not really, it's the same thing. It's just that DBT has a certain way to make it work in DBT of running it, and that is to essentially create a temporary stored procedure, run the stored procedure, and let that produce a table. And that's how DBT chooses to run it to just work within their kind of framework. But yeah, you can run it in different ways. It doesn't have to be running a stored procedure. Cool, I think we've exhausted the questions. Thank you all very much.